Hi, Assalamualaikum. My name is Nur Batrisyia binti Nizam. I'm a first year student of degree in applied physics in USM. So today I'm going to explain to you about electromagnetic cranes. But before we get into that, let's get to know my group members.
Hi, my name is Nurzahira Ishika binti Zuhaidee. I'm a first year student from School of Physics in the program Pure Physics. And in this group, my job is as a scriptwriter.
Assalamualaikum and hello everyone. My name is Siti Humaira binti Sofi. I'm a first year student from School of Physics, majoring in Pure Physics. And my role in this group is as an editor.
So, what are electromagnetic cranes? Electromagnetic cranes are basically used to handle and move heavy metals like steel and iron. The main part of an electromagnetic crane is the magnet. Actually, an electromagnetic crane is a crane that makes use of the link between electricity and magnetism to produce the force required to lift heavy objects. Usually, electromagnetic cranes can be found in recycling plants and junkyard. So, how do electromagnetic cranes work? When the electric current is turned on, the current flows through the wire and a magnetic field will be created. Then hold the steel items and lift them to the designated place. When the electric current is turned off, the magnetism disappears and the steel comes down. Electricity is a phenomenon associated with either stationary or moving electric charge, while magnetism is defined as a physical phenomenon produced by moving electric charge. Basically, electromagnetism is produced when electrical current flows through a simple conductor, and as the current flows through the whole conductor, a magnetic field is created along the whole conductor. An electromagnet is a solenoid around a bar of iron or other ferromagnetic material. A solenoid is a coil of wire with electric current flowing through it. This gives the coil north and south magnetic poles and a magnetic field. The magnetic field of the solenoid magnetizes the iron bar by aligning its magnetic domains. The combined magnetic force of the magnetized wire coil and iron bar makes an electromagnet very strong. In fact, electromagnets are the strongest magnets made. An electromagnet is stronger if there are more turns in the coil of wire or if there is more current flowing to it. A bigger bar or a bar made of material that is easier to magnetize also increases an electromagnet strength. Because of this, electromagnetic cranes are used to carry heavy objects, and as long as there is current flow into the crane will hold up the objects. So why do we use electromagnets in electromagnetic cranes? This is because electromagnets are not as permanent as everyday magnets. By using electromagnets, the magnetic force can be controlled by switching the current that flows through them. So, when there is no electric current, electromagnets stop working. Other than that, in large industrial cranes, extremely strong electromagnets are used to lift heavy objects off the ground and move them from one place to another. While permanent magnets can have large pull forces, they do not have the ability to lift heavy objects. Permanent magnets can also lose their magnetism. So now let's talk about the advantages and disadvantages of electromagnetic cranes. First, let's talk about the advantages. One of the advantages of electromagnetic cranes is the recycling industry can drastically increase the workflow. It takes less time and less manpower to do all the work. However, electromagnetic cranes also have disadvantages. It uses up a lot of energy and can also be dangerous. It becomes dangerous when the current flow is suddenly cut off. The hanging objects might drop and will cause injuries to the workers. In conclusion, electromagnetic cranes are an application of electromagnetism that is usually used to carry heavy metals in the recycling industry. It has both advantages and disadvantages to the industry. So that's all from me. I hope you guys like this video. Bye!